this is part 2. Make sure to watch part 1 first. The link is in the description. In the last video, we focused mainly on reconnaissance, but in this video, we move into manual testing. I'll also show how I was able to achieve command execution on my university server, so make sure to watch till the end. And as always, all content is fully censored and this testing is done legally for educational purposes only. So now let's start with the first issue I observed. This was an image information disclosure issue. What this means is the image URLs on the website were following a very predictable pattern. I noticed that profile images were being loaded using numeric paths, something like this. A folder number followed by an image number, and after every image upload, those numbers changed only slightly. This kind of predictable structure is dangerous because it allows someone to guess other image locations in this case. It meant that other student profile pictures could be accessed just by changing the numbers in the URL. Now, manually changing EIDs one by one is not practical. So instead of doing that, I wrote a small script to automate the process. The script simply loops through a range of numeric values and checks which image paths actually exist. This helps test the issue efficiently. After running the script, it showed that multiple images actually existed. To confirm this, I tried opening those image URLs directly in the browser, and I was able to view all of them without any restriction. Now let's move to the next issue. This one is an IDOR vulnerability. While testing the website, I noticed a problem in the profile image upload feature. This issue allows an image to be uploaded to another user's account without proper authorization. To confirm this, I used Burp Suite. I intercepted the request that was sent when uploading a profile image and analyzed it carefully. Inside the request, there was a parameter that decided which user account the image would be uploaded to. To test this, I changed that parameter to a different user's ID. Then I forwarded the request without making any other changes. The server accepted the request without checking if I was allowed to modify that account. As a result, the image was uploaded to another user's profile. This confirms that the application is vulnerable to an IDOR vulnerability. So now let's test file upload vulnerabilities. So first, I tried the basics. Renaming extensions, changing case sensitivity, using double extensions, manipulating content types. The application was validating the extension properly. So at this point, normal bypass techniques were not working. After deeper testing, I noticed something interesting. The upload process was not handled properly in terms of timing. This is what we call a race condition in file uploads. Let me explain this simply. A race condition happens when the server performs multiple operations during upload, like first saving the file, then validating it, then renaming it, or applying restrictions. If there is even a small delay between these steps, there can be a tiny window where the file exists in its original state before processing fully completes. If someone accesses that file during that small window, it may execute before restrictions are applied. That is the race condition. So after understanding this behavior, the server clearly had extension filtering in place. However, during testing, I noticed something unusual. When I embedded the PHP code inside a valid image structure, but kept the extension as BHPA, the behavior was slightly different during the upload process. The file was still eventually handled by the system, but during the tiny timing window before full validation completed, it behaved differently compared to a plain HP file. That's when I realized the race condition could be triggered more reliably using this approach. Then I sent the upload request to the server. At the same time, I sent parallel requests attempting to access the expected upload path. Since the upload directories were predictable, something I had already confirmed earlier, I could reasonably guess the folder name and file path. So while one request was uploading the file, the other requests were repeatedly trying to access the uploaded file URL. Because of the race condition, sometimes the file became accessible before the server finished processing or restricting it. It did not work every time. In fact, it required multiple attempts, which is completely normal for race condition vulnerabilities because timing must align precisely. But eventually, I was able to trigger execution during that short timing window. At that point, I stopped further exploitation and documented the issue responsibly. This confirmed that server-side validation was happening after the file was temporarily accessible, which creates a serious security risk. And yeah, that's it for this video. part 1 of this series honestly blew up more than I expected. So I just want to say thank you to everyone who watched it, liked it, and especially those who dropped valuable comments. I read all of them. The support on this channel really motivates me to keep making deeper and better content for you guys. If you haven't watched part 1 yet, go check it out. And if you're enjoying this kind of real-world testing breakdown, make sure to subscribe and stay tuned. More advanced content is coming. Thank you all for the support. I'll see you in the next one.